So, lesson 1-9, estimate roots. All right, we're going to be using perfect squares and perfect cubes to estimate square roots and cube roots. So our perfect squares are something that have an integer square root. So that would be like 1, 4, 9, 16, 25. All right, those are our perfect squares. Some of our perfect cubes would be 1, 8, 27, 64, 125. All right. They have they have integer cube roots. Anyway, so we're going to be using that. That's our objective. But first, let's get after some review. Our first problem is writing that number, that decimal, in scientific notation. And then your other 4 problems are below. Pause, try them, then check your work. All right, that first one, we have to write the first part of scientific notation in a number between 1 and 10. So that means the decimal will go there. How do we get it to move there? We have to bump it over 1, 2, 3, 4 times. And so 3.5 times 10 to the 4th, right? Or is it going to be -4, +4, -4? Well, if we want this value to be equal to 0.00035, then do we want to just multiply 3.5 by a bunch of 10s, times 10 times 10 times 10? Or do we want to multiply it by 1/10 times 1/10 times 1/10 times 1/10? Hopefully you said times 1/10, because that would make the number smaller each time you multiply by 1/10. It makes it smaller by 1 place value, right? So that would be the correct answer right there. All right. Cube root of 1,000. Hopefully you got 10. Does -10 work? No, it does not, because -10 times -10 times -10 would be -1,000, not +1,000. All right, we're trying to find the square root of -144. Well, there is none. No real solution. And let's solve number 4. I would go about this by square rooting both sides. The square and the square root are inverse operations, so they cancel out. We just have to remember we get the negative and positive answers for an equation like that. Now I wanted to show one more time, good review about square rooting fractions. We see this plus or minus, so we need to have the positive and negative answer here. We're going to square root the top and square root the bottom and get 3/4 and -3/4. All right, hopefully you're getting better at these types of problems from this chapter. Now let's get into the meat of the lesson. We need a tool. All right, this tool, this number line, will be our go-to tool as we go through this lesson. What we're going to do is we're going to rename each of these numbers, 0, 1, 2, 3, 4, 5, as a square root. Okay, so what is 0? What would equal 0 if we were to write it as a square root? Well, we'd get the square root of 0. All right, how about what would equal 1? Square root of 1. What would equal 2? Square root of 4. What would equal 3? The square root of 9. What would equal 4? Square root of 16. Square root of 25. And so on and so forth. Why don't you go ahead and fill it in and then unpause in a sec to see the answer. There you go. Now you have all of them. Check. Make sure you have them right. Okay, so how are we going to use this to estimate square roots? Well, if I were to give you a square root such as square root of 51, where would this fall on the number line? Look around. Where would it fall? It would fall somewhere in between 49, square root of 49, and square root of 64. So therefore, the answer is going to be somewhere between 7 and 8. Which one's it going to be closer to? Is the answer going to be closer to 7? Or is it going to be closer to 8? The square root of 51. Closer to 7 or closer to 8? Well, since 51 is a little bit closer to 49 than it is to 64, that means the answer is going to be a little bit closer to 7. So we can kind of get a little bit closer to the right answer. Maybe 7.3, maybe 7.2. All right, we'd have to actually do some scratch work to see if we're getting closer. But that gets us in the ballpark. So that's how we're going to be using this. We're going to be finding these values somewhere on our kind of tool here, on our number line tool. All right, we need a similar tool for estimating cube roots. All right, so what cube root equals 0? Well, the cube root of 0. What equals 1? Cube root of 1. Cube root of 8. Cube root of 27. All right, so fill out the rest of your tool and unpause when you're ready. There you have it, the rest of the list. Make sure your answers are there. How are we going to use that? Well, I'm going to say, well, estimate the cube root of 131. And you're going to find it on this tool and say, oh, well, that should be somewhere in between the cube root of 125 and the cube root of 216. So then the real answer is going to be somewhere between 5 and 6. All right, and then you can say, well, is it going to be closer to 5 or closer to 6? Well, the square root of 131 would be closer to 125, so it's going to be a little bit closer to 5. All right, so this is how we're going to use this little tool here. All right, let's get into it. Okay, you're going to have to be coming back to these as we go through the examples. Okay, example 1. Estimate the square root of 83 to the nearest integer. All right, so your answer is not going to be a decimal, not going to be a fraction. It's just going to be an integer. All right, so the square root of 83. First, we're going to compare 83 to the perfect squares you know. So let's go up to our tool, and we have all of our perfect squares in these little square root symbols, the radical symbols. All right. So we got to place square root of 83 somewhere on this tool. I believe it would be right in there. And so therefore the answer is going to be between 9 and 10. And which one's it going to be closest to? Because that's going to be our answer, because we're rounding to the nearest integer. So we're working with square root of 83, so 83 is much closer to 81 than it is to 100. So our answer is going to be closer to 9 instead of 10. So what's the nearest integer? The nearest integer is 9. All right, so let's show some work here. This first part says, 1, compare 83 to the perfect squares you know. So 83 is greater than 81. That's the closest one that I can get that's less than 83. But 83 is not as big as 100. That's the closest one I can think of that's a little bit greater than 83. All right, so that's how I find those, and I can just use my tool to find those, right? I found those up here. That's the 81 and the 100. And now I'm just going to think through, if I square root all of those, I get 9 and 10. So my answer to square root of 83 has to be somewhere in between those. So that's how the book shows it. That's one way to show the work. Using the tool can obviously be helpful. All right, and then you're going to choose, the last step is to choose which integer it would be closest to. Well, because 83 is much closer to 81, your answer is going to be closer to the square root of 81, which is 9. So we're going to say in this problem, our final step is to say 83 is approximately equal to 9. All right, so 83 is approximately equal to 9. We use those squiggly lines because we're estimating or rounding. There we go, to the nearest integer. We could be more accurate and say like 9.1 or 9.2 and test those answers out. But right now we're just going to the nearest integer. All right, let's try it again. Estimate the square root of 59 to the nearest integer. Why don't you try that on your own, pause, and then check your answer to see if you got it. All right, you're back. Square root of 59. Let's go up to our cheat sheet up here. Square root of 59 is going to be somewhere in between here. So the answer is going to be somewhere between 7 and 8. Which one is it closer to? 59, so it's 10 away from the 49, but only 5 away from the 64. So this one is going to be a little bit closer to 8 than it is to 7. So our result would be, the nearest integer would be 8. All right, so we can show our work a little bit by saying, all right, if 59 is in between, the closest one I can think of that's below it is 49, right? Perfect square. The one above it is 64. And so we will square root all of those, and we get 7 is less than square root of 59, which is, and then the 8 is greater than that. So it's somewhere in between 7 and 8, and then we chose 8 to be the winner. That's the one it's closest to because the 59 is closer to 64. All right, so we'll write our answer, 59. Square root of 59 is about approximately 8. Not exactly 8. It's a very, very rough estimate, but that's what we're doing right now. Okay, same directions for this. So to the nearest integer. All right. So 170. Now, I don't think this one's on our cheat sheet. Oh no. But because I've worked hard to memorize my perfect squares, I know the closest perfect squares to this. So I'm going to say 170 is above, greater than 169, which is 13 squared, and 196, which is 14 squared. All right, so then I'm going to root all these to show that the square root of 196 is 13. Square root of 170 is in between these two, and that would be, 14. All right, so then our answer is going to be somewhere between 13 and 14, the real answer, but we're just estimating to the nearest integer, and because 170 is way closer to 169 than it is to 196, we're going to say 13's our closest integer. So the square root of 170 is approximately equal to 13, when really it's not even close to being equal to 13. All right, so same idea. We're estimating cube roots now. So we're going to estimate the cube root of 320. We simply go up and find it on our cube root tool. 320 would be somewhere in there. So that means the answer is going to be between 6 and 7. And 320 is closer to 343. So 7 would be our winner, our closest integer. So when we estimate this, I forgot to put estimate that to the closest integer. All right. So we write down the ones that are the closest that we know of. Our perfect cubes. So we look at our little cheat sheet here. It's in between 216 and 343. And so cube root, cube root, cube root. Okay, we got 6. I'm running out of steam here, guys. And that is 7. And we know that the 320 is closer to 343, so the 7's our winner. So the cube root of 320 is approximately 7, although it's really 6 point something, 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 something. All right, let's order this from least to greatest, our last little problem here. Guess what? We're just going to use the strategy we just worked on to estimate these two, and then we're going to put them in order. And we always remember to write our answer, all the numbers in our answer, in the same form they were given to you in. All right, so we might change them out now, but then we'll change it back for our answer. So 7 and 9, we don't have to deal with them at all, but we do have to estimate what these square roots equal. So we're going to take the 50 first. I know that it's near 49 and 64. And if I root those are my perfect squares. I get 7 and 8. So my answer to this square root of 50 is somewhere in between 7 and 8. So I know that it's going to be greater than 7. So I already know where it's going to fall in my range, and it's going to be less than 9, of course. All right. Now let's do the 85. All right, that's above 81, my perfect square, and 100. So this one's going to be between 9 and 10. So it's a little bit above 9. So now we're ready. I know that this is going to be, why not use a more specific math word instead of above? All right, that's greater than 9. All right, and what do we say this is between 7 and 9, the square root of 50? So now we're ready to put them in order. We know that 7 is the lowest. The root of square root of 50, and then 9, and then the square root of 85. All right. So we can use that estimation tool. Our estimation tool's up here to help us in a lot of different situations. Good luck with the practice, and hopefully you can ask questions if you have any trouble.